Welcome to the surgical theater. Today, we're putting on our scrubs, grabbing our precision instruments, and dissecting exactly how to master one of the most notoriously tricky areas of the Cambridge IGCSE Physics syllabus, energy stores and transfers. If you've been grinding through the 0625 curriculum, you already know that this topic is absolutely foundational. But here's the harsh reality. Knowing the basic physics principles is literally only half the battle. Think of it like this. I see two types of students all the time. Let's call them Alex and Sam. Alex walks into the exam, sees a question on energy, and just overloads the page with raw physics facts. Total brain dump, zero actual analysis. Then you have Sam. Sam is racing the clock, rushing through the paper, and completely misses the specific requirements of the command words. Both of them are bleeding marks, and they don't even realize it. Today, we are going to treat the exam paper with surgical accuracy. We're going to look at exactly how to deconstruct these questions with a steadied hand, ensuring you capture every single mark available to you.
Now, what's really striking about this quote right here is the high stakes involved. This perspective comes directly from a senior examiner who grades thousands of these papers. Year after year, capable students who genuinely know their physics theory, walk into the exam hall and just hemorrhage easy marks. Why? Because knowing the physics isn't enough if you don't know how the examiner actually assesses it. You can't just throw facts at the wall and hope something sticks. The examiners have a very specific rubric. But listen to me closely. After we go through this explainer together, you are going to understand that precise underlying methodology. You are going to stop losing those easy points. And you won't be one of those students leaving marks on the table. We are going to transform those red pen marks into green check marks.
So here's our roadmap for thinking exactly like a Cambridge examiner today. We're going to start by uncovering what I call the energy marking trap. Then we'll lock in the core theoretical foundation of stores versus transfers. Next, we'll dive into the method mark strategy. After that, we'll review the top 3 examiner warnings drawn straight from actual past papers. And finally, we'll equip you with our ultimate problem-solving framework: deconstruct, solve, and evaluate.
Let's move straight into Section 1, the energy marking trap. It's time to start thinking like an examiner.
Okay, you cannot beat the test if you don't know the rules of the game. The crucial point here is that examiners are not looking for you to just list everything you've ever memorized about energy. The assessment framework heavily prioritizes analytical depth over superficial breadth. They are targeting your ability to apply and analyze. Remember Alex from earlier? The student who just overloads the answer with facts? That's the energy marking trap. Cambridge explicitly states that top-performing candidates exhibit connected, conceptual understanding that they can transfer to completely unfamiliar contexts. Before we continue with how to actually decode these questions, subscribe to our YouTube channel Ace the Exams at acetheexams_IGSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, back to the trap. You have to understand that the command words in the question, words like describe, explain, or calculate, are the keys to the surgical precision we talked about. If you just define terms when the command word asks you to analyze a novel scenario, you get 0 marks for that depth.
Let's move to Section 2, stores versus transfers. This is your theoretical foundation. To avoid that trap we just discussed, you must establish a rock-solid, unbreakable foundation. And in the 0625 syllabus, that means strictly separating where energy is kept from how it actually moves. Take a really good look at the left side of this slide, energy stores. These are the physical ways energy is kept within a system. You got kinetic, gravitational potential, chemical, elastic strain, nuclear, electrostatic, and internal thermal. Now, shift your eyes to the right side, energy transfers. These are the active pathways: forces, electrical currents, heating, and waves. You must never, ever mix up the left side with the right side. A store is not a transfer, and a transfer is not a store. This is exactly where our second student, Sam, messes up. Sam rushes through and writes something like kinetic transfer. Boom, marks lost instantly. Conflating the two is literally the quickest way to lose credibility with an examiner. You have to keep these strictly categorized in your head.
So how do we make sure we never, ever miss a store when analyzing a complex system under exam pressure? You need to develop a memory hack. Grab a pen right now and look at these first letters on the screen. K, G, C, E, N, E, I. I highly recommend creating your own mnemonic from this exact list to lock these 7 specific stores into your visual memory. Maybe something like kids go crazy eating nuts every ice cream. I don't know, make it weird. Weird things stick in your brain.
Having a rapid recall memory hack for these 7 exact terms will save you crucial time and cognitive energy during the exam. It frees up your brain to focus on the much harder analytical steps, rather than sitting there sweating trying to remember if thermal is a store or a transfer.
Now we need to connect those two concepts. It is absolutely vital to understand this definition of causal relationships. Energy transfers are the mechanisms. They are the active pathways that act as the bridge moving energy from one store to another. For example, think of a heavy box falling off a shelf. The mechanical force, which is the transfer, moves energy from the gravitational potential store of that falling box into its kinetic store. To structure this perfectly, you should use the Peel framework: point, evidence, explanation, link. Make your point about the initial store, provide evidence from the question's data, explain the transfer mechanism, and link it to the final store. According to principal examiner reports, candidates who explicitly reference these exact cross-topic connections and clearly articulate this cause and effect relationship achieve significantly higher marks.
Moving on to Section 3, the method mark strategy. This is all about earning points for your process. Okay, the theory is great, but how do we actually secure those elusive points on paper? We need a bulletproof process. If there is only one single thing you take away from this entire explainer, let it be the golden rule right here on this slide. This is an official examiner alert. Even if your final answer is wrong, method marks can save you. Show you're working. Multi-stage physics questions are explicitly designed so that marks are awarded for the journey, not just the final destination. You could literally press the wrong button on your calculator and get a completely wrong final number, but method marks can still save your grade. But listen, they can only save you if the examiner can actually see your logic laid out clearly on the page. Stop scrolling. Subscribe to our YouTube channel AC Exams at @ACEXams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @ACEXams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
So, how do we guarantee those method marks? Examiners award them for professional process. That means you must demonstrate strict presentation conventions every single time you tackle a problem. Think of yourself as a working physicist communicating data to a colleague. You need proper headings. You must use the correct terminology, again, distinguishing between stores and transfers. You need appropriate formats and incredibly clear annotation when you extract data. Let's do a quick mental challenge. Imagine I show you a complex physics data table right now. You've got 60 seconds to scan the data. If you just scribble random numbers in the margins, you fail the challenge. If you extract the core trend with clear headings and units, you win. Sloppy presentation completely hides your brilliant understanding and literally physically blocks the examiner from giving you the partial credit you deserve.
Let's look at Section 4, Top 3 Examiner Warnings. We're looking at real pitfalls from actual past papers.
We are going straight to the source here, the direct feedback from the people who are actually holding the red pens and grading your papers. After analyzing years and years of Cambridge examiner reports for the 0625 syllabus, we can cut through all the noise and distill the chaos down to a very specific number. There are exactly 3 major mistakes, 3 massive pitfalls that consistently drain marks from otherwise totally capable physics candidates.
Now, what's truly fascinating about this slide is that none of these top mistakes have anything to do with bad math or forgetting a complex formula. They are 100% about poor exam execution. Mistake number 1, confusing cause and effect. This is what we talked about earlier. Students swap the transfer mechanism for the store. Mistake number 2, formatting. Rushing through like our student Sam, forgetting to annotate extracted data, meaning all method marks are instantly vaporized. And mistake number 3, which honestly is the most tragic one, providing generic textbook answers that aren't specific to the context. If the question gives you a 60-second challenge about a specific roller coaster with specific mass and velocity, your answer must reference the data of that exact roller coaster. If you just write down a generic definition of kinetic energy, you get nothing. Context is everything.
Finally, we reach Section 5, deconstruct, solve, evaluate. This is the ultimate problem-solving framework.
Let's pull all of this together into a fail-proof system for tackling those terrifying multi-stage analysis questions. Top-scoring candidates never just start blindly calculating. They use a 3-step system. Step 1, deconstruct. This is where command word decoding happens. You identify exactly what the examiner is asking, extract the givens, and break the massive problem into logical steps. Step 2, solve. You execute those steps using the Peel framework we discussed, applying clear notation and the correct terminology. And finally, step 3, evaluate. This ties directly into your time management matrix. You look at the marks available, look at the answer you just got, and ask yourself if it makes physical sense within the time you've spent.
So the absolutely crucial point here is that evaluating your final answer and proving its reasonableness is just as important as the calculation itself. The average student stops at step 2. They get a number, they underline it, they move on. The top-scoring candidate takes a breath. They look at their final answer and demonstrate true evaluative thinking. They question their own assumptions and justify their physical conclusions with evidence directly derived from their calculations. This exact level of evaluative thinking is what the Cambridge Assessment Framework is designed to reward, pushing your mark potential from 80% right up to 100%. Students who implement these physics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos.
I'll leave you with this provocative thought to ponder before you tackle your next set of past paper questions. Have you truly mastered the method, or are you just memorizing the theory? Knowing the 7 energy stores and 4 transfers is just the entry ticket to the exam hall. True mastery, the kind that secures those top-tier grades, comes from your ability to deconstruct, systematically solve, and critically evaluate completely unfamiliar contexts on the fly. Here's your final reminder: subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to at acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for physics and the biggest challenge you're facing. Our team responds to every comment. Like and share this explainer with a study partner. Ace the Exams. Your Cambridge success starts here.